Boys and girls, I know you have had a lot of questions about estimation and what strategies you should be using. So I'm going to do this quick little video to try and um, just walk you through what we've been doing in class again. So hopefully it will answer some questions for you. Remember that this is SOL 4.5. The student will estimate whole number sums and differences and describe the methods of estimation. The student will refine estimates using such terms as closer to, between, and a little more than. But remember, this is not the only vocabulary that they can use. They can use simple words such as estimation or estimate or round. Remember, some of the other keywords are things like approximate. We already have closer to, a little less than. We already have between. It may say near. Remember, they may give it a range of answers. So unfortunately, there are a lot of different keywords we're going to be looking at, and the strategies change as the words change, and it also changes as the answer choices change. But remember, our basic strategy that we're always going to use, unless it says to use front-end estimation or compatible numbers, would be to round, round, solve, meaning that you have to round the numbers first and then solve. It also gives you easier numbers to work with so that you don't have to do as much work to find the answer. So remember, we're sticking to round, round, solve. And here's our learning intentions. Remember that we're using all of these skills together. I know it's a lot to cover, but unfortunately this is a power-packed SOL, but we can do it. So we're going to be rounding, adding and subtracting, and even estimating and solving both one-step and multi-step word problems. Keeping these questions in mind, here's one of the big ones. What are some of the strategies for estimating or for estimation? Remember, we did questions like this in class, and our main reason for doing this was to show us that estimation gives us an answer that's close to the actual answer. So we looked at, remember, if a problem is written horizontally, you always want to rewrite the question vertically. With a question like this, it doesn't tell you where to round to, so you would just round to that greatest common. Remember, it has to be one that's the same. Greatest common place value. So this would round to 700. And this one here, remember looking at that two-digit number, 71 rounds to 70, and we just put that 0 at the end. 345, 34 rounds to 30. And excuse my writing, it's a little more difficult to write with the mouse pad. And then we would just put the 0 at the end to make it 300. Line it up. Remember, we can hold our paper sideways so that we have those columns already there, and then we just drop one digit in each column to help us line it up on our just regular old notebook paper. Can help us to line up our place value so that we add correctly, and 7 plus 3 is 10. So 1,000 would be our estimated answer. Remember, we did some of these samples in class just to show us that when we round or we estimate, because remember there are several different types of estimation that we've been covering, that the answer should be close to, or in the neighborhood. 4 plus 5 is 9, 4 plus 1 is 5, and 7 plus 3 is 10. So we should be close to our actual answer when we estimate. All right, we're not going to try the subtraction one. We're going to go ahead and move on. Now, we will have some questions where it will just be straight computation like this, where we'd have to type in an answer choice. But most of our questions are going to appear like this, where you have a question stem and then answer choices. Remember, when there's answer choices, it's important to look at those answer choices because now they're going to dictate where you round to instead of just rounding to that first digit. And if we go through and annotate the sum we're looking to add of 239 and 199, and here we go, best. We know that's one of our other keywords that sometimes clues us into the fact that they are estimating. So now we look at the answer choices, and we would notice that each of these answer choices has been rounded to the tens place. How do we know that? Because we look for the last number that has value, or whole number digit. And the last whole number digit in each of these numbers is in the tens place. Because remember, everything to the right becomes a zero. So that's where all of these zeros came from. So we would need to round our numbers, again, written horizontally. We have to write it vertically going down the page. Round our numbers to the tens place. Again, holding your sheet of notebook paper sideways to give you columns to help you line them up, or putting one digit in each box on a piece of graph paper can help you line up your place value so that you don't add or subtract incorrectly. Remember that we are adding. Sign and the line are important, and circling that sign will help us to know we are adding, because remember, it will fluctuate between addition and subtraction. Unfortunately, that's going to be another added layer that you have to watch those signs. So 239, again, we're rounding to the tens place. 39 would become 40. So 240 is our first number. And then 199, looking at the 99. Remember, this is a little trickier because it becomes 100. We can only put, if we were lining it up like we usually do, 0, 0, then the 1 here. But we have to combine this one with this one. When you have one that goes from like a 99 up to 100, just go back to your original number and look at it and see what would make sense. It would not make sense to take 199 to 100. That means you would have to go 99 places if we were running, remember our 100s grid? If you're running away from that dog, you don't want to go 99 spaces. You want to get as close as you can. So what's right next door? 200 is right next to it. So that only makes sense that it would go up to 200. Again, when we're writing it, we would normally write I won't write it under because there's no space. Our two-digit number here would round to 40. That's really easy because we just put the 40 right there, and then everything to the left, leave it alone. Again, this was a little more complicated. It's 3 digits because it rounds up to 100. But you have to start at the back. 0, 0. Rounds up to 100. We can't leave it that way. We've got to combine them. It's almost like we're regrouping here. So that becomes, again, 200. And I'll take that out of there as not to confuse you because it's not an answer. I'm just showing you the rounding process. And then we're finding a sum. So we add it. 0, 4, 4. Miss Mouton, you must have done something wrong because I don't see my answer here. Well, it actually is because remember, again, we're looking for a range. There's that magic word between. So where does that 440 fit? It fits between 350 and 450. So letter C would be the correct answer choice. Remember, that's just one way to do it. Again, looking at the key words, making sure you read all of it though, and then looking at the answer choices, because in this type of question, the answer choices are going to dictate what answer you're going, excuse me, to choose. Here we go again. Here's another one. This one is finding the difference now between 912,642 and 405,927. Best described as, here's another group of keywords, a little more than. When we look at our answer choices this time, though, you notice that everything has been rounded to the hundred thousands place. So where are we going to round these numbers? To the hundred thousands place. And again, here we're finding the difference. You could even annotate that sign to help you know that that's where we're rounding to. These questions are a little easier than the ones that you typically see, ladies and gentlemen, so you have to pay close attention. Lining up your place value using either your graph paper or your lined paper. Remember, we don't put the answer under here because this would be the exact answer. You would have to actually subtract those. It goes over here because this is the estimated answer. So looking at that 100,000th place, 91 rounds to 90. And everything to the right becomes a 0. We had nothing to the left, so we wouldn't have to worry about that this time. And look how easy can that get. 40 just stays right there at 40. Everything to the right again becomes a 0. And then we subtract, finding the difference. Sign and the line. 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0. Miss Mouton, why is that important to go from that? Because you have to establish those patterns of always making yourself go from the right to the left. Never jump here, because if you do it once, you could possibly do it again when you should not. We don't want to do that. 9 minus 4 is 5. There's your answer, ladies and gents. Letter H, 500,000. Okay, on to the next problem. This is where it gets extremely tricky. They give you the question up here, and this is a Hampton City Schools document that they gave us in our teaching, because they know that we can see questions that look like this. And we want the sum of, sorry, it's so small, 32,796 and 47,580. And again, best described, and here are our answer choices. Now, here's the trickiness of it all. On the last ones, we were looking for the 0. And some students might be fooled by the fact there's a 0 here. But if we go one space over, there's another whole number digit telling us that we did not round to the 10,000th place. Here they actually rounded to the hundreds place, because remember the rule is everything to the right would become a 0. If they had rounded to the 10,000th place, this digit here would have to be a 0, and it's not, telling us that this is where they rounded to. And that's what made this problem very tricky for some students. And I'm going to type this one in, so our box is so small. 32,796 40. Oh, sorry. Larger number always goes on top. That way, and they will give it to you out of order like this, so expect that that will happen. That way, in case you are subtracting, you will never ever try to subtract a larger number from a smaller. If you just always establish the rule that I'm going to put the largest number on top. Now, we've just found out we're rounding to the hundreds place. So we're going to round these numbers to the hundreds place. And I'm going to do that again. 5 is in the hundreds place. Let me click this back over. Next door is an 8. So we're looking at the 2-digit number 58. We know 58 rounds to 60 because it's closer to it. An estimation is giving us an approximate answer, close to, not an exact answer. So there's our number. Everything to the right became a 0, and it happened to already be a 0, so that was pretty easy. And this one, 32,796. 79 is our number. What's it right there with? 80. So we're going to round it to 80. So 32,800. That 6 becomes a 0 because it's to the right of the place that we rounded to. And we're going to add them this time. 0, 0. 8 plus 6 is 14. Write down the 4. Regroup your 1. 7 plus 2 is 9, plus the 1 you regroup makes 10. That's where that extra 0 came from. That 0 there, that was the tricky one. 4 plus 3 is 7, plus 1 is 8. 80,400 is your answer, so that would be the correct one. Be careful when you're walking through these that you look at all the digits. It has to be everything to the right is a 0 in order for that to be the place that you round it to. And I know it's, remember we talked about that computational fluency. It's going to take some time for you to really look at each of these questions and decide which strategy they're using to solve it, or which strategy you should use to solve it. Going on to the next problem. This is where it gets a little tricky. We have to look at the verbiage that they use in the text, or the words they use to describe it, the vocabulary that they use, in order to know what are they specifically asking me to do. This time Joan is using front-end estimation. And remember, we can cry tears of joy when we see front-end estimation, because we know this is going to be an easy problem. Because front-end estimation tells us we're just taking this front digit on each of the numbers, and then everything else becomes 0. It is one way of estimating. Remember that it always gives you an answer that's going to be lower than your original answer, because no matter what numbers come behind it, it could be 9999, we drop them off and turn them into zeros. So they want to know which ones have an estimated difference of 20,000. And remember, this is your TEI type question, and you will have some like this, which means you're going to have to round all of these first, but we're not going to fret over it, because we're just going to use front-end estimation to round them, which is really easy. And then after we do that, we're going to have to subtract them in pairs to find out which one has a difference of 20,000. And Miss Mouton's just going, sorry, type it again. 3 is the first digit. Everything else just becomes 0. 2 is the first digit. Front-end estimation. Everything else becomes 0. 6 is the first digit. Everything else becomes, everything else becomes 0. 7 is the first digit. Everything else becomes a 0. Don't forget your commas. And the last one. And again, we said this is really easy. They're all 5-digit numbers. So all we really have to do is look at that first digit. So would it be 30 minus 20? Again, looking at the difference, so we have to subtract them. I'm not going to do each one down here just for the sake of time, but we could do the first one, 30,000 minus 20,000. Again, we don't even have to look at these zeros, but make sure when you do have digits that you're lining them up correctly. These are all going to be zeros. And 3 minus 2 is 1. So we know these two don't work. So we have to find another combination until we do find one that when we subtract them, the answer we get is 20,000. And I know we did this one in class and we kept combining them. 60,000 minus 20,000 is 40, so that doesn't work. 70,000 minus 60 is 10,000, so that doesn't work. And then we found that 30,000 minus 10,000 equals 20,000. So those were our two answers. And it would probably end up being a TEI type question. I don't know if it's going to let me do it. Oh, it didn't. Figures. But a TEI type question where we would end up clicking on it and it would just end up shading in this as our answer, or highlighting it as our answer. Okay, so that's front-end estimation. Here's another tricky one, unfortunately, and I'm sorry that estimation has so many different strategies you can use, but it's just how it is. But we're going to make it through, because you're going to use your computational fluency to decide which strategy to use, which sum is between 5,000 and 5,500. This is another tricky one, because they put this 500 in here, we'd have to round to the lower, because we have to use that commonplace value. All of these are zeros, so we have to round to the hundreds place on each one of these. So because if we don't, we actually will not find an answer choice here that works. So this one would become 2,500, because that 48 rounds up, plus 1,200, 3,100, and 2,700, because the 65 becomes the 70, 1,600, and 1,200, 3,600, and 1,500. 500. And what we end up finding when we finish all of them is, I apologize, I don't remember our answer from class. And it's late. Miss Mouton's brain is tired. Mercy. So we're going to end up with 3,600 and I'm going to have to work it out, guys. I'm sorry. The brain is just not cooperating. And 1,500. Remember that for each one of these, it's a TI type question. So we actually have to work it out. And then remember that you're adding. Put your line in your sign. Some of y'all have been getting a little bit lazy with that. 3 plus 1 is 4, plus the 1 you regroup makes 5. And ooh, wonderful, wonderful. I picked the correct one. So D would be the answer. And we would find out some of these would be too small. They would fall in the range over here. Some of them ended up being too large. They would fall in the range over here. We need one that comes in between those two. And that one happens to be the one that works. There we go. Same thing, round it closest to. This is easy enough. We can see clearly that they rounded to the 10,000s place. So it would be 30,000 because this guy right here became 90,000 and this guy became 60,000, and 90 minus 60 is 30,000. Here's the last one that we're going to look at. On this one, we have multiple, so this is our multi-step problem. They show the number of marbles that Juan had in 3 jars. We want to know which is closest to the total number of marbles in the 3 jars. So we're going to be using all 3 numbers here. And if we look at our answer choices, again, they are rounding to the tens place on these answers. So we have to round all of them to the tens place, which would make sense, ladies and gentlemen, because here 37 doesn't have a hundreds place. So we couldn't possibly round it to the hundreds place. And we can take the largest numbers first or the smallest numbers, whatever you choose, round them all to the tens place. So let's start with 180 because it's already rounded to the tens place. We could take 121. That's pretty easy. We round it to the tens place. 21 becomes 20. Add that. 8 plus 2 is 10. Regroup your 1. 1 plus 1 is 2. Plus 1 is 3. But we're not done yet because remember we have to add all 3 jars. Here's your multi-step. This is a pretty easy multi-step, but there will be some more complex ones than that. But the big thing here is you have to remember that we're rounding. I give you this closest to, and your answer choices are the hint that you're actually going to do that. So we already used 180. We already used 120. Now we round our 37. Because it's a 7 here, 37 rounds to 40. And remember, here's the other thing we're going to resist doing. Don't just slap the answer, the next add in under there. Rewrite, because if you should have to regroup, you all are forgetting there's not enough space here. You're squishing your numbers, and you're forgetting to add in those digits that you regrouped. So be careful to not get lazy and not rewrite. Please take the time to rewrite. It will pay off. There you go. And there's your answer. Again, it's important that you follow the steps, no matter how silly it might seem. Miss Mouton, I could just throw the 40 under here. But when we did some examples in class, lots of you were forgetting to add those numbers that you had regrouped up here because you wrote it too small or it was sloppy or you couldn't see it. And then you forgot to put it in. Remember, every single mistake you could possibly make. I know here they don't have them, but it will be that way when you take your test. Every mistake you could possibly make will be one of the other answer choices, meant to distract you. It's not fair, it's not nice, but it is what it is. And at least if we know what it is, we can try to avoid some of the typical pitfalls. I hope this video helped you. Please go back and watch it again if you need to. But these are the types of questions you're going to see on your quiz on Friday. one front-end estimation. The only thing we didn't cover was compatible numbers, and that's basically when you look at those numbers and go to what's reasonably closest to it. That won't be a difficult question, but we're going to, you will have some examples on your homework for Thursday evening as well. If you have any questions, remember that you can always email me, and I'll try my best to answer your questions. And the answers to the homework will be on the homework hotline as well. I hope this helps to clear it up for you a little bit. And tomorrow we'll be working, or today we did work it again. Today's Thursday in class. So hopefully that helps some of you as well. Please take the time to just stop and look at the problem and ask yourself the question, what are the clues that show me what the strategies are to solving the problem? What are the answer choices, if there are any there? And will they give me any clues on how to solve this problem? Thanks for watching, ladies and gentlemen, and I'll see you in class.